Hey everyone, welcome back. So we have already solved two sum problem. So today we are going to solve upgraded version of two sum. So the problem is three sum and it also a medium problem from the Leetcode, and in this problem we are going to use two pointers and sorting. You can also use map to solve this problem, but today we are going to focus on using two pointer and sorting. Basically we have already covered two pointers, right? But sorting means before solving our problem we just have to sort our array. That's what it is, sorting. Okay, you can think like that to solve this problem we have to sort our array, or without sorting you won't be able to solve your problem. So let's see what is the problem. So we have given a array something like this, and you have to find three values such that the sum of these three values will be equals to 0, and there is other condition that I should not be equals to j, I should not equals to k, and j should not equals to k. That means you cannot take single value for these three values, so you have to take unique value for every answer, and you have to find multiple answer. Means in this problem if you take -1 and 2, so the sum is 0. So -1 and 2, so we made one array which containing sum 0. Now you cannot take this same array again because it will create a duplicate, so we have to avoid duplicate also. So the next possible array we can make -1, 0 and 1. So 0, 1 and -1, this one or this one does not matter. So we were able to make another array. Now if you try to make another array which gives you a sum 0, it is not possible in this example. Okay, so you have to return these both of the arrays. So the problem is that you have to find three values such that their sum is equals to 0 and their index are not same, right? So our first solution will be brute force, right? In this case we have to find three values. So if we want to find three values, that means we need three iterators, I, j, k. So our I will be here and j will be here and k will be here. So if my I and j is here, then my k will move to find the third value. So we were able to get our first answer. So similarly my k will move again, then again. Means at every iteration we are trying all the possible values which will give us a sum of 0. So if we write a program for this, first we will run a loop for a ith index, right? Now we will run another loop for the jth index. Now our j will always start from the next value of the ith, because we cannot take from the same position. If we take value from the same position, then one of my condition will fail, which is that I should not be equals to j. So we have to avoid same index. So we will start our j from the I plus 1 until n and j plus plus. Similarly we will write another loop which will be next to the j, right? Because if we start from the j, they will be at the same index. If we start from the I, it also from the same index, but we have to avoid it. So we will start from the j plus 1, then k less than n, k plus plus. After writing these three loops, we will check my nums of I plus nums of j plus nums of k equals to 0. Then we can push these three values into our 2D vector. Basically it will be a 2D vector because we are going to have a multiple vectors in a single vector, so it will create a 2D vector. So here we will push our answer. So it will keep running until all three iterators will finish their iterations. So the time complexity will be nq, right? Because we are running three loops and all of them are nested, and the space complexity will be 3n, right? Because here we are only storing three elements every time and number of rows can be n, so space complexity can be 3n. So overall will be n, and it is not a extra space, it is a answer space. So you can also write your space complexity as a 1, but if you asked that what is the answer space complexity, you can say it is 3n. okay, so you can run this program, you will be able to get your answer. But the time complexity is nq, and the constraints we are having is that 3000 means our inputs for n can reach 3000, but we have n q, so it will around 10 to the power 9, which is greater than 10 to the power 7. So the code will not run, and we will get a TLE, which is time limit exceeded, right? Because online server can run up to 10 to the power 7 number of iterations or inputs, so the 10 to the power 9 will give you a time limit exceeded. So for this, let's write a optimized code. So before moving that, we are going to use 2-pointer and the sorting. So basically in this case technique is 2-pointer, but we have to use 3 pointers, I, j, k, because we want 3 values. So we have this array again, right? So we need something I, j, k to move these 3 pointer and get us some 0, but controlling 3 pointers is not possible. So decided that we will fix one of the pointer. So we will not move our I based on any condition, we will move I as usual, means we will just iterate over the array using I. So our I is fixed, so we won't be controlling the movement of the I. But now we have j and k, we already solved 2-pointer problems, so we can easily control the 2 pointers j and k. So now the j and k can be moved. So let's say we have I, j, k here, and -1 plus 0 plus 1, it is 0. We will be able to got our 0. Now what is the condition to move our j and k, right? Let's say I moved my k here, so -1 plus 0 plus 2, it is 1, not an answer, right? So again I moved my k here, I am moving my k blindly because I don't know what should be the condition to move my j and k. So to create a condition where I can make my j and k dependent on some condition, so for that I will sort this array. So it will be -4, -1, -1, 0, 1 and 2. Okay, so I have I here, j here, and I will start my k from here. So now I will move my j and k. So -4 plus -1 plus 2, it is not an answer, right? It is not an answer. But what is the sum? It will be -5, 3, right? Now if you look at it, our array is sorted, okay, and we have sum 3 which is greater than, sorry, -3 which is smaller than 0. So if I want to move towards the 0, right, if I want move towards the 0, I need to add something, and it should be bigger value. So if we want a bigger value, we will move our j, right? Because if you move your k, you will be moving towards the smaller values, but if you are moving your j, that means it is moving towards the greater values. So we jumped here and reached at the -1. So let's again take a sum. So it is again -3, so it is still less than sum. So we will move our j again. Okay, let's take sum. -4 plus 0 plus 2, it is -2, but it is still less than 0. So we will move our j again. So let's take -4 plus 1 plus 2, it is -1. It is still less than 0, right? Now we cannot move our j to the k, because if we move, that means j will become equals to k. The condition will fail. So in this iteration we weren't able to get our answer. That means with the -4 we won't be able to get our answer. So now we can move our I here, and we can reset our j and k again. Okay, so let's remove this. So now let's take some -1 -1 plus 2, it is a 0. So our sum becomes equals to 0. That means we were able to get our answer. So we will just insert these values to the array. Now we will move our j to the next, then -1 plus 0 plus 2, it is 1. This time our sum is greater than 0. That means we have to reduce our sum, so it will achieve 0. So we will this time move our k. So our sum will become -1, 0 plus 1, it is 0. So we were able to get another answer. So we will also push this answer into the answer vector. Okay, so till now we were able to get our answer. Now we cannot move j and k, so now we will move our I again. Now we have I here, j, then k here. Okay, so if you take a sum -1 plus 0 plus 2, it will be 1, so sum is greater than 0, so we have to move our k. -1 plus 0 plus 1, it is 0, our sum is 0 equals to 0. But if you look at it, here we have -1 0 1, but we already gotten -1 0 1, so that means it is creating a duplicate and we have to avoid the duplicate. So for this we have to write 3 extra conditions to avoid duplicates, which is that when we moved our I, we have to check that our previous value is not equal, right? These values should not equal, but in this case it is equal, so we should have skipped our I to this pointer, so this time we were jumping 2 position, not a 1. Okay, so to avoid the duplicates. Similarly for the j and k, we will also do this, because let's say if you have 1 here and you took 1 with the help of k and again you moved here, then 1 comes again, there is a chance that will make your answer duplicate, so we will also skip this k also, so we are jumping 2 times instead of once to avoid the duplicates. So let's write a code. So first we will declare our array size, then we will sort our vector, right? After sorting it, let's also declare a 2D vector to store our answer. Then we will run a loop, it is for the I, because it is not moving according to the condition, so it will keep running. Okay, now first we have to avoid the duplicates. So here in this case we had a -1 at this position, initially I was here, then we moved here, so we have to check that if we are at this I, that previous I should not be same. So we will check my current I is equals to nums of I -1, means my current value equals to previous value, then we will continue, means we will skip that iteration. Okay, so just like break statement, there is continue statement which skips that whole iterations. Okay, here we are ensuring that my I is greater than 0, means if I try to do 0 -1, it will become -1, so we have additional condition, so the index will not go into the out of bound. Okay, so this condition will skip my similar values. This is only for the I. Similarly we have to handle the j and k also. Now after this we will declare j, which will be starting after the I, and we have k which is starting from the ending, and we will run a loop j less than k. So as long as j is less than k, we will keep running our loop, and here we will take sum, because sum can be a large value, that's why we are taking long. So here we sum all 3 values. Okay, now we will check if sum greater than 0, that means I have to reduce my k, because we will be able to get a smaller value at left side. Okay, similarly else if my sum is smaller, that means I need a greater value, then I will move my j. Else my sum is equals to 0. If it is equals to 0, we will push back all 3 values into the answer array and move our j and k, because we already took these values. Now we have to write extra while loops here. Make sure that it does not take duplicate values, so it will keep checking if the current value is similar to the previous value, it will move, right? So j++. Similarly for the k condition. So these are extra loops which making sure that we do not take duplicate values. You can take this example like this. So if we have j here, right, and if we moved our j in the next iteration, it is checking for the previous, it is the same, that means j will move here. It will again check, it is the same, that means j will move again. So our j move again and again until it is not similar to the previous value. Similarly for the k, it will move again and again until it is not similar to the previous value of the k. Okay, so let's write a code because here it got little messy. So here you given a problem, you have to take triplets such that I not equals to j, I not equals to k, and j not equals to k, and the sum should be 0. And here they have written one more statement, solution set must not contain duplicate triplets. So there should not be any duplicate triplets. Okay, let's first declare our array size int n equals to nums dot size. Then let's sort our array, also declare our 2d vector to store our answer. After this we will run our loop. Here we will write a condition to make sure that our value at the current I is not equal to the value at the previous I. If it is equal, we will continue, means we will skip this whole iteration. So nums of I equals to nums of I minus 1 means it is same. That means we will continue this whole iteration. After this we will declare j, which is I plus 1, and our k, which is n minus 1. After that we will run another loop which will be iterating over the j and k, and here we will take sum nums of I plus nums of j plus nums of k, and if sum greater than 0, that means we will decrease our k, else if sum less than 0, we will increase our j, else our sum is equal, we will push back the triplets into the answer, nums of I comma nums of j comma nums of k, and we will move our j and k. Also we will write two while loops also to handle the duplicate values. So j less than k and nums of j equals to nums of j minus 1, we will move our j plus plus. Similarly for the k, here we will write k and k plus 1, and we will move k minus minus. After for loop we will return our answer. So here you can see our solution got accepted. So this is our whole code. So in this we are using sorting and 2 pointers, and we are keeping our I fixed here. So I is not depending on any condition. Here we are checking if our current value equals to the previous, that means we will skip this whole iteration. Okay, and we are controlling our j and k based on the condition which is sum. Okay, and these loops are basically skipping the similar values, and the time complexity of this problem will be n square, because we are running one loop here and we are running another loop here for the j and k. So the overall time complexity will be n square, and the space complexity is same as the previous space, because it is only taking space complexity for storing the answer, not for solving the problem. So you can also solve this problem using map. So try it yourself. That's it for today. Until then, thank you everyone. Have a nice day.